Good day, students. Welcome to math.serve.com. In this clip, we're going to be going over problems 16 to 20 of the Algebra 1 Common Core New York Regents exam for August 2016. All right, let's take a look at the question. 16 paragraph reads, Kendall bought X boxes of cookies to bring to a party. Each box contains 12 cookies. She decides to keep 2 boxes for herself. She brings 60 cookies to the party. Which equation can be used to find the number of boxes X Kendall bought? So before we get started setting up the equation, let's take a look at the formula that's going to aid us in constructing the different components of our equation. All right, so formula is as follows. Total amount is equal to unit amount. So how much do you have in each unit? Unit amount multiplied by the quantity. All right, so that's the formula we're going to be using. Now, in our equation, there are 3 terms, okay? And they can be described as follows. First of all, the first term can be determined by considering the total amount of cookies. Total amount of cookies bought. All right, so did Kendall take the total amount of cookies she bought? Did she take everything to the party? The answer is no, she kept some cookies, right? So we're looking at the total amount of cookies minus the cookies that she kept, okay? Cookies kept for herself. When you carry out this difference, what you'll be left with is the amount of cookies that she brought to the party, okay? So cookies brought to the party. Okay, so we're going to determine each component of this equation using this paragraph that's provided for us. Let's start with the first part, the total amount of cookies bought, okay? Total amount of cookies. All right, so how much cookies did Kendall buy? We're told that she bought X boxes and each box contains 12 cookies. So the unit amount is 12 cookies per box and the quantity of boxes she bought is X. All right, so unit amount, 12 per box times the total number of boxes, X. Multiply this to yield the expression 12X. Now, how many cookies did she keep? Cookies kept. We're told that she kept 2 boxes, right? But how many cookies are there in a box? You always have 12 cookies in each box. So the unit amount of 12 times the quantity of boxes she kept for herself, which is 2, gives us the total amount of cookies that she keeps for herself, which is 2 times 12, 24. The last component is the amount of cookies that Kendall brought to the party. That was clearly provided for us, okay? If you read the problem, it indicates that she brings 60 cookies to the party. So cookies brought to the party is simply a total of 60. Now, what we're going to do is we're going to take these values and substitute it into their corresponding parts in this equation right here. So the total amount of cookies she bought is 12x minus the cookies she kept, 24, equals the cookies she brought to the party, total of 60. Okay, so this is the equation that we can solve to determine x, the number of cookies, the number of boxes that she bought. Okay, so answer for number 16, let's see, is option number 3. Okay, let's take a look at 17. It reads, the table below shows the temperature T of M of a cup of hot chocolate that is allowed to chill over several minutes M. Question, which expression best fits the data for T of M? So we have 4 options here for functions that we're to consider to determine which one best fits this data that is provided. Okay, so we can use our calculator to do this with no problems. So what we're going to do is enter these four functions into a calculator. Okay, so let's do the first one, 150 times 0.85. Now we're going to raise it to the x power. The independent variable of these functions are all m, but the only independent variable that the graphing function in this calculator accepts is x. Okay, so t of m can be viewed as t of x in the calculator language. All right, next one is 150 times 1.15 raised to the x power for m. Next one is 150 times 0.85 raised to the, now we have two terms in the exponent, okay? We have m minus 1. So we have to group them together in their own parentheses as x minus 1. All right, last but not the least, we have 150 times 1.15 raised to the x minus 1 for m minus 1. All right, so what we're going to do is we want to create the table of values that generates the output for 02468. So we're going to go to second function window for our table setup. Now, let's see. We want to start from 0 and we want the input values to grow by 2. Okay? If you don't want to do that, you can ask the calculator to ask you for the input values and you just enter 02468. Okay? So press second function graph. That takes you to the table. Now to take a look at y1 represents the first one, okay? So let's see. 0, 150, 2, 108, 4. Oh, this is perfect. If you look at the first one, that's exactly what we want. All right? Take a look at the second one, option 2. Option 2 is, whoa, it starts wrong. It's 17640. That's totally wrong. Option, actually, that's not option 2. Option 2 is, okay. Option 2 is 150, which is good, and it goes to 198, which is terrible. So our answer cannot be 2, so we scrap that out because it doesn't work. We already know that the answer is option 1, but I just want to show you how the others look just to satisfy your curiosity. Y3, 176, that's an automatic fail because for 0, we need 150. Y4, 130, it's wrong right from the first input value. So we can clearly see that the only function that best fits this data is option 1, okay? As you can see right here. And remember, when we're entering the functions, y1 is the first one, okay? So you gotta keep track. Answer to number 17 is option number 1. All right, let's take a look at question number 18. It says, as x increases beyond 25, which function will have the largest value? Okay, so we're looking at output values. We're comparing the output values of these four functions. Now, what kind of functions are these? The first one is an exponential function. Second is a linear function. Third, a quadratic function. And the fourth, a cubic function. Now, one thing I want you to keep in mind, this is very important for high-level math courses, is that at higher values of x, as you tend towards infinity, the fastest growing function is always an exponential function. Okay, as long as the base is positive and the power 2. So you have an exponential, you have the fastest growing function being the exponential function. So in this scenario, I'm already having a bias towards option 1 because this, at very high values of x, I don't know if 25 is big enough, the exponential function will always dominate, okay? But we can't make that assumption because 25 is not that big, but it might be sufficiently large for f of x to demonstrate its rapid growth. So what we're going to do to know for certainty what the biggest function is after 25 is to compare the output values for each of and every one of them at a value bigger than 25. How about 26? So for option 1, we're going to see what is f of 26? What is the output when plugging 26 into this exponential function? For option 2, what is g of 26? Option 3, what is h of 26? Option 4, what is k of 26? Okay, so what we're going to do, we're going to fire up our calculators and enter these four functions into our calculators and compute their output when the input value is 26. Okay, 1.5 to the x is the first one, f of x. G of x is 1.5x plus 3. H of x is 1.5x raised to the second power. Option 4 is 1.5x to the third plus 1.5x to the second power. Enter. Okay, so let's do the following. I'm going to go to table setup. Okay, what I'm looking for is I want the calculator to tell me the output when the input is a specific value. So instead of auto, I'm going to say ask. Ask me what you want uh, what output I want you to calculate. Okay, that's what ask means. So we go to the table, and what are we entering? 26, right? So 26, enter. Now what happens is that the calculator computes the output for all four functions as you can see here. Okay, so let's write them down and carry out our comparison. For the first one, f of 26 is 3788. 37, was that 88? I don't remember. 37877. 37877. The second one, 42. The third one, what is it? Scroll to the right. Third is 1014. And the fourth one is 27378. 27378. So what are we supposed to do with these values right here? We're looking for the largest. Okay, so the f of x is the largest, has the largest value. Beyond 25. Okay, so our answer to number 18 is option number no. All right, let's take a look at question 19. It says, what are the solutions to the equation 3x squared plus 10x equals 8? Okay, so this is a quadratic equation. We're going to be solving this quadratic equation using the method of factoring. Okay, now why did I use the quadratic formula, completing the square, or other methods? Well, if you look at the options, whenever the options are all rationals, fractions or whole numbers, then you know for a certainty that the quadratic is factorable. Okay, if we had radicals or imaginary numbers, then you cannot factor it. Okay, you just want to use the quadratic formula because that always works. Factoring only works when the quadratic is factorable. Okay, so one quick reminder is that quadratics must be placed. Quadratics must be placed in standard form before solving by factoring. Okay, even if you want to use the quadratic formula, for some by factoring or the quadratic formula. So you always want to make sure that it's in standard form. So what on earth is standard form? Standard form is basically the ax squared plus bx plus c equals 0 form. All right, you set all the three terms of your quadratic equation equal to 0 in descending order. All right, the quadratic given to us is not in standard form, so please be careful with that. In order to achieve that, we just have to set it equal to 0, move the constant to the left by subtracting 8 from both sides. That gives us the quadratic in standard form, 3x squared plus 10x minus 8 equals 0. Now let's proceed to factor. Okay, now in this case, the factorization requires us to use factoring by grouping because a is not equal to 1, okay? Had it been a were equal to 1, we can jump from this x game to the factored state, but we do not have that luxury here. AC goes on top, B goes on the bottom. A is 3, B is 10, C is negative 8. AC is 3 times negative 8, which is negative 24. B is positive 10. Now this is the question. What two numbers multiply to yield negative 24 and add to give 10? So to assist us with the different combination of numbers, what we're going to do is look for the pair of integers that multiply to give us 24 and see which one combines to yield 10, either by addition or subtraction in any order. Okay, first pair, 1 times 24 is 24, good. If you add these two, you get 25. If you subtract, you get 23. So we don't have 10, so this pair doesn't work. 2 goes into 24 12 times. The sum is 14. The difference is 10. Oh, no, that's nice. So let's test it out. Now, one thing that you want to keep in mind is if a pair works, that doesn't automatically make it the correct pair. Like, let me show you something. In this problem, for instance, had we gone 3, 8, which is 11, 5, and 4, 6, guess what? 4, 6 also gives you 10. 2, 12 gives you 10. Okay, so which one is the correct one? So the fact that one combination works does not automatically make it the correct one, because sometimes you have multiple combinations that work, but only one should be able to satisfy this x game. Okay, so let's test the first one we came up with. 2 and 12. Can we manipulate the signs in such a way that it works? Since the sum is smaller, it has to be a difference. Since the result is positive, that means the smaller has to be negative. Okay, so let's test it. What is negative 2 times 12? Negative 24. Excellent. What is negative 2 plus 12? Positive 10. Perfect. So this works nicely for us. Okay, now let's see. We're going to now factor by grouping. So we're going to rewrite our polynomial as 3x squared. Instead of 10x, we're going to replace it with negative 2x plus 12. Where did these numbers come from? Our x came right here, okay? Now, divvy down the center. You do your split right in front of the sign of the middle of the third term, like that. So we are now going to factor out the GCF from the two parts of our partition. On the left side, what is the GCF? The GCF here is x. Okay, so we factor out x, and then we divide these two terms by x. 3x squared divided by x is 3x. 2x divided by x is 2. Plus, now, on the right side, we're going to factor out the GCF, which is 4 in this case. 12x divided by 4 is 3x. Negative 8 divided by 4 is negative 2. Now, this is where you want to freeze and check, okay? If you carried out your factoring by grouping your axiom, everything correctly, at this point, the quantities in the parentheses must be identical. Is that the case here? Yes, so we're looking good. Now, these two identical quantities, guess what we are going to do? We're going to factor it out, right? Because that's what we're doing with factoring. Factor out 3x minus 2, and you are left with x and positive 4. Group those two together in their own parentheses, equals 0. Now we're going to set each factor equal to 0, okay? And then solve using the zero product property. 3x minus 2 equals 0, and x plus 4 equals 0. Actually, this is the zero product property. So let's go ahead and finish this off. The first one, in the first equation, x can be isolated by adding 2 and dividing by 3, right? So we have 3x equals 2. Divide both sides by 3. Final answer, x is equal to 2/3. There goes your first solution. Second solution, simply subtract 4 from both sides, and then you get x equals 4. I'm sorry, negative 4. So what are your solutions? your solutions are -4 and positive 2/3. Okay, so let's see. Bam, option number 1 is the correct answer for problem 19. All right, let's take a look at problem number 20. It says an online company lets you download songs for 99 cents each after you have paid a $5 membership fee. Question, which domain will be most appropriate to calculate the cost to download songs? All right, so first thing we're going to do is remind ourselves of what that word domain means. What on earth is the domain of a function? Okay, so let's recall. What I'd like you to recall is that the domain is basically the constraints on the inputs. Okay, constraints on the input value. Okay, another word for constraints is what's acceptable, what is appropriate. So acceptable inputs. All right. Okay, so let me just give you an analogy. If you think about digestion, the digestion of the human body as a function, what are some acceptable things that the stomach can digest? They can digest like cookies or soda, but if you take in something like a rock, it's not digestible, right? So acceptable inputs into a function are known as the domain values of a function, okay? So what makes sense? What can go into the function in order to generate a desired or acceptable output, or a defined output, to be more mathematical. Okay, now there are two parts to the equation. Domain is the constraints on the inputs. We also have the range. Now, what's the range? The range is the constraint or the constraints on the output values. Okay? What are some acceptable output values that you can generate with these acceptable input values? Okay? So, our acceptable output values. So in this particular problem, our attention is focused on the domain. All right, so let's give ourselves some idea or examples of the what the numbers look like for each of these options. Then we'll create our function and see which of them is acceptable, are acceptable input values for our created function. Okay, so first one, it says rational number is greater than 0. So what you want to remember is that rational numbers are simply integers or whole numbers and fractions. Okay, so rationals are integers, whole numbers, plus fractions. Any number that can be expressed as the quotient of two integers is rational. So what are some examples of rational numbers greater than 0? You could have 0.5, 1, 3 over 2, which is equal to 1.5, and it just goes on and on and on. Okay, whole numbers and fractions greater than 0. Number 2, whole numbers greater than or equal to 1. So what are some candidates, some examples? Since it could be 1, we have 1. 1 is a whole number. 2, 3. Just you're counting numbers all the way to infinity. Option 3, integers less than or equal to 0. So since we're looking at integers less than or equal to 0, we start from negative infinity. Dot, dot, dot. So start all the way from negative infinity to -4, -3, -2, -1. It says less than or equal to 0, or 0, bam. Stop right there. And then option 4, whole numbers less than or equal to 1. So let's see, whole numbers less than or equal to 1, we have 0 and 1. These are the only two values that satisfy this option here, option 4. Now, which of these ones are the good domain values for the cost to download songs? What does a function look like? Let's create a function real quick. So what is the cost function? Okay, we have a base rate and um, a growth rate. The base rate is $5. That's your base fee. So that's going to be our y-intercept, B. And then this is the growth rate, how much you pay per song you download. So that will be our M. Okay, you remember the equation, y equals mx plus b, right? So we're going to be using that to generate our function. Our cost function, C of x is equal to the growth amount, 0.99, x plus the base amount, which is 5. So this is a function for calculating the costs to download X amount of songs. Now we're focusing on the constraints on the input or output. Domain is input, okay? So the constraints on the input, that is what we're considering. What is the input for this function? In order to determine the cost of the song, you want to if you want to determine the cost to download an amount of songs, you need to know the number of songs. Okay, so the domain, let's write it out so we know exactly what we're looking for. The domain is the constraints, or are the constraints. Domain are the constraints on the number of songs. Okay, so if you count the number of songs that you can download in order to determine the cost, what makes sense? That's the question that we're going to be considering. Okay, so thinking about number of songs. Option 1, rational numbers greater than 0. 0.5. Does it make sense to download half a song? We want to pay money just to download half a song. That makes absolutely no sense, right? You download complete songs. Okay, so option number 1 is not an appropriate representation of the domain of this function, namely the number of songs downloaded. How about option 2? Can you download one song? Yeah, 2, yeah, 3, 4, and on and on and on. So option 2 is perfect. This is the answer that we're looking for. All right. But let's just take a look at the others so we know for certainty that option 2 is the best representation of the domain of the function. Integers less than or equal to 0. Can you download negative songs? You try and download a song and you find out that you're missing songs from your computer. That makes no sense, right? You cannot download negative songs. So option 3 is not an appropriate representation of the domain. Option 4, how many songs are there in the world? Do you just have 0 or 1 songs? There are thousands, millions of songs. I don't know how many there are exactly, but there are really, really many songs. So this would be appropriate if you have only 1 song in the world. That makes no sense, so option 4 is not appropriate for the representation of the domain, okay? Option 2 is the correct answer for number 20. Thanks so much for taking the time to watch this presentation. I really appreciate it. If you found the contents of this tutorial helpful in your preparation for the Algebra 1 Common Core Regents exam, to give us a thumbs up. Your positive feedback is very valuable and supportive to us. If you have any questions, just place your questions in the comment section below, and we'll be more than glad to assist you. Don't forget to subscribe to our channel for updates to the remainder of this review series. More clips can be found on math.serve.com. Thanks again for watching and have a wonderful day. Goodbye.